this particular computation algorithm for the real-time application, because I am working with the Naval Research Board, DRDO. Based on their requirements only, I have actually developed some mathematical models connected with the real-time experimental data. And based on that model only, we have implemented several wavelet-based algorithms for solving the highly non-linear as well as the fraction order differential equation models for predicting the values, not only the predicting values but also the estimation of the various parameters included in the ship dynamical models. So that is the validation is an important thing of the real-time experimental data. So based on the experimental data only, the corresponding mathematical model needs to be developed for the validation part. Once the model is developed for the data set provided by the real-time experiments, then we shall use the efficient computational algorithms for getting the solution for analyzing the behavior of the system. So behavior of the system can be analyzed through the solution of the mathematical model and the corresponding computational algorithms and the solution procedures only here. So in my past 15 to 20 years of research experience connected with the various wavelet-based algorithms for solving the highly nonlinear as well as the fraction order differential equation models in various sciences and engineering, I am focusing a few computational algorithms which are connected with the operational matrices algorithms for solving the highly nonlinear as well as the fraction order differential equation models for validating the real-time data actually. So based on the experimental study provided by the NSTL lab, actually we have connected with the Naval Research Board, DRDO, and the NSTL member Professor Bharadwaja and other Selva Ganesh. They are scientists. They are working on their the ship hydrodynamics models. In my work, I have actually connected based on the loading condition, based on the ship loading condition only, we have to predict the various parameters included in the ship dynamical models. That is why I am insisting a few open problems related with this particular study actually. For the first time we have implemented these kinds of the algorithm as well as the models that we have quoted in this particular slide, and the theoretical validation has been done successfully with respect to the experimental data provided by the NSTL lab members actually. So we have connected with the real-time data set as well as the prototype models that we are doing here. So that is the thing. Actually now I will go to the presentation of this particular thing. So the outline of my presentation consists the various aspects here. That is the abstract of this work, the newly developed this paper, the corresponding work has been published in Ocean Engineering Journal of Elsevier as well as the ships and offshore structures in Taylor and Francis. So we have actually published more than 10 papers connected with the more than 10 SCI indexed papers connected with this domain. So that the next important thing is the build skill model. Build skill is an important geometry in ship actually with respect to the stability, more stability of the ship with respect to the load. Load is another important aspect. So based on the loads only we have to design the ship structure. Not only the basic structure. So we are having some kinds of the AI based ships. We are having both all the things, all the ships have been manufactured through these ideas only. So based on the real-time data set only with respect to the load conditions, we will develop the appropriate mathematical models and the efficiency and the behavior of the prediction model can also be analyzed by using the various computational algorithms. And then mathematical formulation of the model, the ship dynamical model that has been quoted here, and then wavelet-based algorithms that we have classified here, and then classification of wavelets, and then operational methods algorithm have been used to solve the kinds of highly nonlinear as well as fraction order differential equation models in the real-time data set actually that we have provided here. The method of solution for the ship dynamical models have been quoted in this, and then research and discussion has been given in that. Then finally we have concluded some important points connected with the real-time data that we have given here. And these are all some of the abstract of this paper. Actually, the research work connected with 4 or 5 papers connected with that. The estimation of ship motion in waves is important for ship design for operation. In this research, a mathematical model of ship roll damping is discussed in this ship hydrodynamics models we have. The several non-linear as well as the fraction order differential equation model can be predicted for validating the real-time data. So validation is an important aspect of the ship, because in ocean engineering people, they are doing only the real-time experimental data only, either by prototype models as well as the real-time model maybe. But prototype model, most of the laboratories in DRDO laboratories are connected to the prototype models only. The real-time data set has been obtained from the NSTL lab Visakhapatnam for the validation of the model as well as the computation of the solution of the nonlinear as well as the fraction order differential equations arising in the ship hydrodynamics here. And then some numerical examples that we have predicted for validating the real-time data that we have given here. And then the machine learning based algorithm connected with the Legendre wavelet method we have quoted in this particular case. So the hybrid techniques in order to increase the time history level only the machine learning multi-layer perceptron approach has been implemented, has been coupled with the Legendre wavelet method solution for validating the real-time data. Also the proposed results are validated with the experimental data provided by the NSTL lab Visakhapatnam, and the satisfactory agreement with the experimental and HPM. HPM is a semi-analytical method for solving the highly nonlinear as well as the fraction order differential equation models in engineering. So that we have taken that particular solution for the numerical validation of this particular study, and then efficiency of the method has been proved by using the computational CPU runtime that we have carried out by using the earlier works and the proposed work that we have quoted in this particular thing. So this is the general structure of this particular work here. The estimation of the ship roll motion, the parameters of the ship roll motion models in ship hydrodynamics, we are having the damping coefficients, restoring moments, and moment of inertia. We have some kinds of the velocity and the acceleration. All parameters are included in the ship roll dynamical system. Therefore, we have estimated the various parameters with respect to the real-time data set. Actually, we will predict the models with respect to the real-time data set provided by the lab. Actually, both the prototype models as well as the real-time data set provided by the NSTL lab Visakhapatnam for validating the data here. And we have estimated the nonlinear differential equation as well as nonlinear damping coefficient model, cubic nonlinear damping coefficient model, and all the things here. And then the Legendre wavelet based algorithm has been implemented for the finite domain in order to increase the time history level for the real-time validation. We have implemented the machine learning based algorithm. Here actually we have implemented the multi-layer perceptron approach in machine learning for predicting the large time history level of the nonlinear as well as the fraction order differential equation models with respect to the real-time data. So this is the basic explanation about the 6 degrees of freedom in ship actually. It has been surge, sway, heave, roll, pitch, and yaw. So there are several ship roll motion on that. So based on that only we have considered a few degrees of freedom, 1 or 2 or 2 degrees of freedom that we have considered here, that the roll and the pitch have been taken in my study actually. So especially roll damping is an important thing because ship's capsize is an important thing, critical in ship dynamical thing. In order to overcome that particular thing only, the model to be predicted with respect to the load condition as well as the environmental condition. We are also for considering the load as well as the regular sea conditions as well as the irregular sea conditions. The model to be predicted on that. Then the model is connected with the highly nonlinear and fraction and some kinds of fraction order model for tuning that particular model for getting the better prediction. That has been done here. This is the build scale geometry in the ship actually. A few applications have been developed for these kinds of problems so far here, in that the build scale is a pair of longitudinal parts of this. The two sides we have the roll response experiment of the ship model with and without build scale under irregular wave condition. That is very important thing. So before that actually, the irregular wave condition we have So based on that only, irregular sea conditions, irregular waves has been carried out for wave height of 3 centimeter, and the periods we have, wave periods we have 0.75 seconds, 2 seconds at the interval of 0.125 seconds on that. So the build skin is an important geometry to avoid the ship capsize of the ships actually, so that only with respect to the load, therefore it is used to reduce a ship's tendency to roll. Build skills are employed in pairs, one for each side of the ship, bottom of the ship. This is the structure of this build skill actually that we have quoted, and then a ship may have more than one build skill per side, but this is rare actually. Build skills increase hydrodynamics resistance to rolling, making the ship roll less and also reducing the collision in regular sea conditions here. So we are considering both regular as well as irregular conditions, as well as the environmental condition will also be taken care of, the better stability with respect to the load that we have given here. And then this is the real-time model. The data set have been data set values have been provided by NSTL Vishakhapatnam. That is actually the DTMP model 5512 model that is available in our DRDO. So based on that geometry only, we have taken the various parameters included in the ship roll dynamical system, and we have validated the results with the model that we have predicted, both the integer order model as well as the fractional order model equation, and we have validated with the numerical data in provided by the HPM, homotopy perturbation method that we have taken on that. We have also solved the equation by using the HPM method, that is homotopy perturbation method, for the numerical validation point of view here. So this wavelet based numerical roll decay simulation will be made for the DTMP 5512 hull. This is the real time ship is available, data sets are available in the laboratory session. They are providing the data set for the real time validation for my study. So the DTMP model has been constructed here, and then the corresponding thing has been, this is the corresponding model suggested by Zing and McHugh in the basic model that has been suggested here. This is the highly nonlinear model. I is the total moment of inertia, B is the nonlinear damping coefficient, and K is the nonlinear restoring moment coefficient, and theta is a roll angle here. This is the simple degrees of freedom problem model here. It's a basic model for this. We are having the highly nonlinear B1 theta dot as well as B2 theta dot, like that here. This is B1 theta is highly nonlinear, as well as B2 theta dot comma theta is nothing but here. So these are all we have actually the damping coefficients we have. So based on the damping coefficient, the original equation has been constructed in this form. This is the highly nonlinear form. This is the B1 type of damping and restoring model. This is the basic model that we have given. So suggested by Zing and McHugh in the year 2011 is a basic model, and based on that only the complicated nonlinear model has been reduced to the simplest model. Then only we can solve by using the dimensionless parameters we are having. So with the help of the dimensionless parameters, the original equation has been reduced to this particular equation here. This particular equation, this is the reduced model equation by using these kinds of dimensionless parameters that we have used on that. Here GM is the transverse metacentric height, GZ is the righting lever, and IX is the mass moment of inertia for rolling, and delta X is the added moment of inertia, and theta dot and theta double dot are roll angle, roll velocity, and roll acceleration. So based on that parameters here, M1, M2, M3 are the arbitrary coefficients here. With the help of that only, the original nonlinear equation has been converted into a simplest form of the nonlinear equation here, which is highly nonlinear we have. So based on that only, we have taken this particular thing. So now I am considering, so once the model is predicted for validating the real-time data only, the efficient computational algorithms to be implemented for solving that kinds of model equation. So for the past 15 years of study, actually we have implemented several wavelet-based algorithms from Hoare and Legendre, Chebyshev, and because most of the orthogonal polynomials have been converted into the wavelet transform methods, provided the multi-resolution analysis properties are satisfied. MRA properties satisfied here. So what are the desirable properties of the wavelets here? The compactly support we have. This is the general introduction about the wavelet function. function that you have known. I will skip this particular thing. The classification of wavelet transform methods like OR, Legendre, Chebyshev, Matthew, and Debichev all are connected to discrete wavelet transform methods. For continuous, we have Shannon and Mexican hat, and several wavelet methods have been developed with respect to the specific application. With respect to the specific application for this domain, actually, here the desirable properties of this is the basic definitions of wavelet. It has two important properties: translation, dilation properties. Already you have known about that. Therefore, I will skip the fundamentals about the discrete as well as continuous wavelet transform methods. These are all the desirable properties of wavelet for solving the differential equation models here, especially the nonlinear differential equation models. The compact support we have, the dyadic relation, and then orthogonal as well as orthonormal. So these are all some kinds of desirable properties for the wavelet transform. So every orthogonal polynomial has been converted to the wavelet transform method, wavelet transform, provided the multi-resolution analysis properties are satisfied. Therefore, the Legendre polynomial has been converted into Legendre wavelet, provided the multi-resolution analysis property is satisfied. Similarly, this other kinds of Chebyshev polynomial has been converted into Chebyshev wavelet. Similarly, the Bernoulli polynomial has been converted to Bernoulli wavelet, and so on. Several discrete wavelet-based algorithms have been developed to solve the highly nonlinear as well as the fraction order differential equation models so far in the literature, actually. But we have implemented more than 15 to 20 discrete wavelet transform methods have been used to solve the highly nonlinear differential equation in various science and engineering application problems, especially the chemical engineering application problem, the biological science application problem, as well as the other kinds of application problem that we have carried out in my study in the past 15 years of study related to that. And then only I shall take this particular tool, especially the operational matrix methods have been implemented to solve the highly nonlinear as well as the fraction order differential equation models in ship hydrodynamics for the first time that we have established on that. This is the thing that we have quoted in that. These are all the basic fundamentals of the multi-resolution analysis properties. Nestedness will be there, as well as the dense. We have intersection of Vj equal to 0, and then if f of t belongs to V0, then f of 2 power jt belongs to Vj. So these are all the basic properties connected with the multi-resolution analysis in wavelets, actually. And then these are the significance of these proposed algorithms, operation matrix algorithm for solving the highly nonlinear as well as the fraction order differential equation that we have quoted in this particular thing. So the collocation method all the methods that we have taken in this study are the collocation methods, actually. So the section of the collocation point is another important research, actually, in solving the nonlinear differential equation. The selection of the collocation point. So collocation point is nothing but the roots of the polynomial, so that the appropriate collocation point to be selected for solving the kinds of nonlinear as well as the fraction order differential equation models in that study, actually. That is the thing as an important thing here. So most of the operation matrices are sparse types of matrices, therefore it has more zeros, actually. When we are having the operation matrix of derivative or operation matrix of integratives, we are having more zero entries in the matrices. Therefore, the computational CPU runtime will be getting reduced by comparing with the Runge-Kutta method as well as the other conventional numerical treatments for solving the nonlinear as well as the fraction order differential equation models. That is why the operation matrix methods have been highlighted in this particular the ship dynamical related application problems that we have quoted. These are all the advantages of operation matrix methods. We are having the simple, easy to analyze, and then the main purpose of this equation is either differential equation or either ODE, annual differential equation, or partial differential equation, or fraction order differential equation model. The differential equation will be converted into a system of algebraic equation. That is the purpose of this particular thing. So the original equation will be converted into a system of algebraic equation by using the operational matrices of derivatives or operational matrices of integratives for solving the equation here. Once the algebraic equation has been converted for the nonlinear as well as the boundary condition we are having on initial conditions we are having on that depending upon the real-time situation, then the collocation point to be selected for solving that equation for getting the quality solution on that. That is an advantage of this proposed method that we have quoted. And then we have actually the thing. This is the Genoa-Key polynomial is a recently constructed polynomial approximation method for solving the highly nonlinear as well as the fraction order differential equation arising in shift dynamical models here. This is the basics of the Genoa-Key polynomial is Gn of x actually here. Then here this is the fundamentals about this actually, sorry. This is the thing, Gn of is the Genoa-Key polynomial of degree n. This is the general definition about the Genoa-Key polynomial here. And then once differentiating d by dx of dn of x equal to, this is the relation n gn of minus n of x in n greater than or equal to 1. So then we have got one property connected with this gn of 1 plus gn of 0 equals 0 for n is greater than 1. So based on that, the operational matrix of derivative has been constructed. This is the Genoa-Key vector. Based on that only, we have g dash of t is equal to mg per t of x. So based on that only, this is the general method for constructing the operation matrix of derivative. Sorry. Yeah, sorry. This is the procedure for constructing the operation matrix of derivative in Genoa-Key polynomial here that we have quoted. So we have the n by n operation matrix of derivative on that and corresponding the notations that we have used in this particular thing, and then we skip the basic thing of this thing. So these are all the basic about the Legendre wavelet that we have known about already. This is a very good polynomial, very good wavelet based algorithm method for solving the highly nonlinear as well as fraction order differential equation models here. Similarly, Chebyshev wavelets method have been used to solve the highly nonlinear differential equations. So many papers that we have published related with this particular thing by various leading journals, applied mathematics, computation, applied mathematics, modeling, and several papers have been published connected with this particular Legendre and Chebyshev wavelet methods actually that we have quoted. So this is the procedure for working procedure for constructing the operation matrix of derivative by using the Legendre wavelet method for this case. And then also we are having the Lucas wavelet method because Lucas polynomial has been converted into Lucas wavelet provided the multi-resolution analysis properties must be satisfied as well as the compact support we have, and then the orthonormal properties have been satisfied on all the things here. So we have, this is the basics about the Lucas wavelet method. So based on that only, this is the relationship between the recurrence relation for Lucas polynomial that we have quoted and the collocation point that we have quoted in this particular thing, the roots of the polynomial that we have. This is the working procedure for constructing the operation matrix of derivative on that, and then this is the corresponding based on the experiment data provided by NSTL lab. Actually, we have predicted some equation. So this original equation is a basic equation that we have quoted for our study. Actually, we are predicting the appropriate mathematical equation, nonlinear equation part of the study here. This particular equation, this particular model suggested by Spyrow Thompson in the year 2000 here. A is a measure of the amount of bias here. Its parameter lies between 0 and 1. If A is equal to 1, then the restoring moment is the cubic polynomial of a symmetric type. Similarly, A is 0, a restoring moment becomes the second order polynomial. Similarly, several cases that we have quoted in this, the corresponding model has been constructed on that. And then this is the appropriate model with respect to real-time data. Is we have the simple, we have the model here. So this equation has been solved by the Genoa-Key polynomial operation matrix of derivative method that we have quoted with respect to the collocation point that we have quoted for the final solution theta of t. That is theta of t is a roll angle with respect to time variable. And then there are some examples that we have quoted in the study with respect to real-time data. So these are all the things that we have given, appropriate models, t belongs to 0, 1, and then these are all the some various comparative study with respect to the Legendre polynomial as well as the homotopy perturbation method for the study for getting the roll angle parameter with respect to the time variable in seconds that we have quoted for all the things. Our solution has been coincide with the solution obtained by the Legendre wavelet method as well as the homotopy perturbation method that we have quoted in the studies actually, and then we have actually compared with the experimental data in the next case. These are some numerical validation that we have done in this case actually for various examples that we have quoted, and then these are the corresponding the real-time data. Actually, we have the mass properties of this, mass properties, breadth, we have the draft, the center of gravity, all the things that we have quoted. These data sets have been provided by the NSTL lab Vishakhapatnam for providing the experimental experimental validation. So every experimental data should be validated theoretically here. Therefore, the corresponding the appropriate model has been predicted for this case. Actually, this is the prediction model connected with this. Then for taking the original process already I have quoted here, the nonlinear as well as fraction order differential equation will be converted into a system of algebraic equation by using the operational matters of derivative or operational matters of integrative in wavelet transform method. Not only the wavelet transform method, but also the polynomial approximation method. Several polynomial approximation methods have been developed for converting the nonlinear differential equation into a system of algebraic equation. Then system of algebraic equation can be solved by the conventional Newton's method for getting the coefficient, the wavelet coefficient. So the either PD will be converted into ordinary differential equation, then ordinary differential equation will be converted into a system of algebraic equation, then system of algebraic equation can be solved by the conventional Newton's method for getting the solution for the model. Actually, that is the thing, that is the process idea connected with this. And then this is the thing we have quoted, the methodology that we have given, and the corresponding damping moments we have constructed on that, and the corresponding the restoring moments that we have calculated, and then we have validated for small values of k and m only in the Legendre wavelet method that we have quoted, k equal to 0 and m equal to, we are constructing 3 by 3 operational matters of derivative. For small values of k and m, we have obtained the very good quality solution when compared with the real-time data that we have analyzed here, that we have quoted. And then these are all the comparative study connected with our proposed solution and the real-time experimental data, as well as the computation CPU runtime can also be has been determined for the method, the proposed method and the homotopy perturbation method results that we have quoted here. Actually the computation CPU runtime is very less when compared with the homotopy perturbation method that we have shown in this particular slide actually. So this is in order to increase the time list level for the real-time experiment only, we have used the machine learning algorithm, especially a multi-layer perceptron method has been coupled with the solution obtained by the wavelet based algorithm here that we have quoted here. So we are having the basic structure about the machine learning that we have quoted for the prediction of the values, and then this is the thing that we have quoted for the validation part of the MLP procedure has been implied here. Popular feed forward network, that is multi-layer perceptron method, has been used with the for validating the real-time data for more than 500 times seconds and more than 1,000 seconds with respect to real-time data that we have quoted in this particular study. And then the validation has been done successfully by using this particular method that we have quoted in this. We have forecasted the values up to the next 50 seconds for angle with respect to the high accurate rate that we have done and this particular work actually. So this is the appropriate mathematical equation. Now the model is connected to the Duffing equation model, is initially suggested by Taylor in the year 1990. This is the highly nonlinear differential equation model arising in the ship dynamics approach that we have quoted in the study. This the final equation has been suggested by Taylor in the year for numerical validation only in this particular problem here. And then the various aspects of the parameters that we have quoted, all parameters have been obtained from the NSTL lab Visakhapatnam for the validation of the real-time data that we have quoted in all the things here that we have done. And then this is the experimental validation with the Range-Kutta method, because only RK method as well as the computation fluid dynamics method have been implemented for handling these kinds of models arising in ocean engineering application. But we have implemented the operational matrix based wavelet methods. Various types of discrete wavelet methods have been implemented for solving the nonlinear equation, nonlinear ship roll dynamical equation model, not only nonlinear. In order to get more prediction, we have constructed the fraction order differential equation model. So in order to tune the prediction system only, we have used the capital sense fraction order differential equation model for this particular application. This is the first time we have used on that we have quoted in the study. And this is the liquid cargo model in ship actually. This connected the barge-like vessel model was designed to process similar kinds of characteristics on that. So the experiment data provided by the NSTL lab actually, they provided the experiment data for barge-like of models here, and then the corresponding mass properties that we have quoted. This is the prototype models that we have obtained here. This is the theta dot is the angular acceleration, angular velocity, roll angle displacement, all the things that we have mentioned in this particular thing. The basic model suggested this ZOW in the year 2016, connected with this ball-like models here. Ball's legs of ship model here. This is the corresponding, the frequency, the Fourier expansion connected with this nonlinear equation here, and then the initial condition that we have quoted, and then based on that only we have implemented the Lucas-Vaillant based algorithm. Lucas-Vaillant based operation matrix algorithm has been developed for solving the equation. The original equation has been converted into a system of algebraic equation with respect to the original equation as well as together with the initial conditions we are having. So we have actually three system of equations that we have obtained here. The appropriate collocation point has been used to solve the kinds of equation for the real-time validation part of the study. So this is the validation part has been comparative study of roll angle with the extended experimental data that we have. So for various time values we have validated the results with the real-time data set with respect to our own algorithm. So in the comparative study of roll angle with the LWM numerical experimental data that we have quoted in this study, so excellent validation has been done for small values of K and M in parameters in wavelets that we have predicted in all these methods that we have quoted. And then this is the corresponding model particulars of FPSO model in ship dynamical system. All data set have been provided by the NSTL lab Vishakhapatnam as well as the Bhattacharya and the Ananda Subramaniam in Ocean Engineering Department in IIT Madras. They are also using some kinds of models, connected prototype models connected with these kinds of nonlinear equations here. That we are getting some kinds of prototype data sets from Indian IIT Madras, Professor Bhattacharya and Professor Ananda Subramaniam. They are working on that for prototype models connected with that. Not only that, we have also collaborated with the NIOT Chennai. They are also working with these kinds of models actually. We have collaborated with the Rajshekhar of scientists NSTL lab, NIOT Chennai. He provided some data set for the real-time validation here that we have got here, and then these are all some kinds of equation. So these are all these various parameters suggested by the real-time data, and for 5 degree, 10 degree, 15 degree, and 20 degree for full condition, intermediate condition, ballast condition. There are three conditions that suggested by the real-time data data set provided by the NSTL lab actually, this one. And then these are all the appropriate models have been predicted with respect to the real-time data, and we have implemented the Legendre-Vaillant based collocation method that we have used on that for K, Lucas-Vaillant method has been used on that for K equal to 0 and S is equal to 3 on that we have given the numerical treatments on that. And then this is the thing that we have quoted. This is the 1 degrees of freedom model, is a basic model actually in ship dynamical system, and then the corresponding initial condition and the conditions that we have given, and then this corresponding validation has been done with respect to the various the numerical the machine learning method and the existing method experimental data that we have validated here with respect to the cases 1, 2 and 3 that we have quoted earlier. Some examples that we have quoted, and then fractional order ship dynamical model has been implemented, has been predicted for validating real-time data. That is the thing. Capito sense of fractional derivative has been used on that. This is the general model has been suggested by Spiro et al. In the year 2008. So appropriate the initial value problem has been predicted by our research groups and connected with that alpha equal to 1/2, and we are taking all the parameters suggested by the real-time data and for the numerical validation on that by using the LCMM method that we have quoted earlier, and we have actually successfully validated with the real-time data. And not only the real-time data, numerical validation has also been done. HPM method, homotopy perturbation method has been implemented for solving that particular for the first time. For the first time we have implemented both the methods for solving these kinds of highly nonlinear as well as the fraction order differential equation models in ship dynamical approach, ship dynamical models here. And these are some references connected with that particular thing. I think this actually last reference before that Taylon paper and barge and with and without bridge skill. Several papers are very useful for getting this the validation part of the study actually. The first the author Rodriguez, that also very useful paper for this particular problem. Thank you very much to all.
Thank you, Professor Hariharan, for a very interesting talk on how the mathematical analysis can be applied for SIP design. And he has also demonstrated how the mathematical results can be validated by the actual experimental results by the agencies, the national laboratories. He is working in close collaboration with Naval, that is ship design, isn't it? Naval Research Board. The data set, the experimental data set is provided by, is it open, sir? Is it open data set? Restricted. We have to register and obtain from them, yeah. So it is a very interesting thing, and it also exposed us to various methods based on wavelets and homotopy perturbation method, and also the correlation, how they fit well to each other. So the validation is very good. We wish you all the best, and we will receive 1 or 2 questions. Okay.
Highly non-linear differential equation. Focus on that. It will be helpful. Yeah, I think in order to validate the real-time data set only we have to predict the model. The earlier model is the basic model, the second model is small model. It is non-linear. So depending upon the real-time data set, we have to predict what are the resources qualities, sampling qualities, and what are the events of that. So based on the resources, moment sampling, sampling qualities, model, we have to predict some kind of non-linear.
Yeah. Non-linear means we have actually
highly non-linear differential equation. When you say that the equation is a highly non-linear one.
Yeah, because
that is actually required.
Yeah, because we have theta power 5 is there, sir. In the roll angle, we have actually one degrees of freedom model we have quoted. In that, the roll angle is one of the important parameters for the ship roll dynamical system. So theta power 5 is there. So that is actually the dependent variable with respect to the more than.
Highly, you mean that?
Yeah.
Because of the power.
Yeah, power. Theta power 5 we have. Similarly, theta into theta dot in magnitude we have. So some kinds of oscillation depending upon the situation here. Then only that particular term has been predicted on that.
Highly non-linear.
Yeah. Yeah. No, we have implemented more than 20 wavelet transform methods for the same problem. Most of the cases, Chebyshev wavelet as well as the Legendre wavelet method have been used. The accurate prediction have been obtained from these 2 methods only, Legendre as well as Chebyshev wavelet method, among the 20 wavelet methods. So we have the error we have 10 to the power -4 or -5 only for small parameter values of K and M. That's very important thing. No, that is a working procedure in wavelets actually. PD will be converted into O form. Then ODE along with the initial conditions will be converted into a system of algebraic equation. Then once the algebraic equation converted for the data for the problem, then we can use the Newton's method for getting the solution.
So it will be time consuming, no? So PD to ODE, then ODE to then algebraic.
But actually,
it takes a lot of time.
That's once you develop the MATLAB for because we are using the sparse steps of matrices. Once we just enter the sparse steps of matrices, it has more zeros, so that the computation time will be getting reduced when compared with the RK method that we have proved on that. Yeah.
We have a lot of students working on wavelets.
Yeah.
It was a very useful talk. I wish they will be benefited by it. But for my information, for the benefit of students also, we try to make it an operational matrix. The whole story is to get a sparse matrix, and that will force you to sacrifice some important component from the equations. So my concern is, why should you not live with the problem as it is? Let it be a dense matrix. Then deal with that. I don't know how much we are sacrificing. You have to check it because it is very popular. Many are using that. We have used it. At the time we didn't know much about that. Respect. ಇವರೆಲ್ಲದರಲ್ಲ ಭಾಳ ಜನ ಏನು ಮಾಡ್ತೀರಾ? They have done good work. Good work. Take the help of Professor Hariharan. Then he was talking about ship hydrodynamics. Professor Chand, ship hydrodynamics. Ship hydrodynamics was studied theoretically in a very perfect way only by a Russian mathematician. Oh, Krylov. 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 An administrator, a mathematician, engineer, 1950s. Now can you imagine? We have a cryo-substrate methods.
Correct.
One of the biggest topics in mathematics, very hot topics in mathematics, because it has come to the rescue of big data analysis and all that, where we were struck. Very important topic. Krylov was a ship hydrodynamics man, and he did a lot of, and his job was, because I have 10-15 books on that cryo-substrate methods. His job was to get a minimal polynomial for a given system of equations. How to get that one? Then he was able to get a useful model and all that. Krylov, Krylov, Krylov-substrate methods. Good. Thank you very much.
So we thank Professor Hariharan by clapping. Thank you very much.
Thank you, sir. On behalf of Mathematics Department, Karnatak University, Dharwad, I would like to thank Professor Hariharan, sir, for his special lecture, and P.S. Hiramet, sir, for chairing this session. Thank you, sir.